The area of a figure is the amount of space on the inside of that figure. The most common way to think of the area is if we had, for instance, a 4" by 5" rectangle like this, we could divide it into a bunch of individual 1" by 1" squares. You can see there's 5 inches in this direction and 4 in this direction. So it is 4 inches by 5 inches. And in total, we end up with 20 of these little squares. 4 times 5 is 20. And this actually leads us to the generic formula of the area of a rectangle. You would just take whatever your length is times your width. And it doesn't really matter which one you call your width and which one you call your length. You could say that this is 4 times 5, or 5 times 4. You know, I'm calling the length 4 and the width 5 the first time. The length is 5, the width is 4 the second time. It doesn't matter. This is just multiplication, so those two are equal to each other, and also that's just dependent on the orientation of this particular rectangle. You know, it would have the same area. It would have the same amount of space on the inside of it if I oriented the rectangle like this. So the area of this rectangle would be 20. Now, you'll notice we're taking inches times inches. So inches times inches, generally when we're multiplying something by itself, we write it as squared. So this would be inches squared. And we would call that square inches, like this, square inches. Similarly, when we take feet times feet, we can write that as square feet. Those mean the same thing. All right, the perimeter of a rectangle, well, the perimeter of any polygon you get just by adding up the length of all the sides, and the rectangle is nothing special here. But if you think about the rectangle, well, if this side was 4 inches, then that means this side is 4 inches. If this side is 5 inches, that means that side is 5 inches. So when we go to add them up, I would take, actually let me call this a length, a width, a length, and a width, so I can do it kind of in general. If I was to add these up, I get length plus width plus length plus width. And, well, L plus L is 2L, W plus W is 2W. We end up getting this formula right here. The perimeter is equal to twice the length plus twice the width. You could memorize that formula if you'd like, or you could just know the perimeter of any polygon is just the sum of all the sides. Alright, so if we wanted to find the area and the perimeter of I, J, K, L, this quadrilateral right here, this looks like a rectangle. Well, the area is going to be length times width, which will be 42 centimeters times 18 centimeters. I'll ask my calculator to do that for me. 42 times 18 is 756 square centimeters. Yeah, it doesn't look like I need to do any rounding or anything like that. The perimeter, I'll go ahead and use the formula here, but you could also recognize this is 42 and this is 18 and just add the 4 sides up. I'll do 2 times 42 plus 2 times 18. 2 times 42 is 84, 2 times 18 is 36. 84 plus 36 looks like it gives us 120. And this being a distance, if we were to go all the way around this thing, I guess I didn't find the perimeter of this first rectangle, but if we were just adding these things up, this is just going to be in centimeters. Notice this is not in square centimeters. This first rectangle that we saw, 2 times 5 plus 2 times 4, that's 10 plus 8, which is 18. This was in inches, so this is going to be just 18 inches. So a square inch and an inch are definitely not measuring the same thing. A square inch is the amount of area covered by one of these little squares. An inch is the distance of one of its sides. Alright, a vent must have an area of 64 square inches. If the height of the vent is to be 12 inches, what should the width be? Well, the area, we know, is equal to the length times width. This is, I guess it doesn't say it here, but I'm going to assume this is a rectangle. So a rectangular vent has an area of 64 square inches. I say it's a rectangle because that's the examples we were just doing. We know that 64 square inches must be equal to the length times the height, L times We're calling it a height here. We had length times width. Again, what we're calling these individual dimensions doesn't really matter. There's two dimensions. One of them we'd call the length, the other one we'd call the width. If we called it a height here, that doesn't really matter which one we plug it in for, so I'm just going to plug it in for the W, more or less arbitrarily. To solve this, we'd want to divide both sides by 12, and you can see L would have to be, actually let me do it this way. On this side of the equation, we just get the L left over. On the other side of the equation, 64 divided by 12 is 5.3 repeating. So 5 1/3 inches. This doesn't have any mention of rounding or anything like that, so I'm not going to worry about significant digits. I'm just going to leave it as 5.3 repeating.